Hi, boys and girls. Welcome back to Mr. Cedarbach's geometry class. Today, we'll be starting Chapter 7 with Lesson 7.2.1. So go ahead and open up your ebook to that lesson. Pause the video if you need a second. And don't forget to take out your pencil and paper and write down today's lesson target. Feel free to pause the video if you need a second to get those out and to copy it down. Are you ready to get moving? Let's go. Lesson 7.2.1, what can congruent triangles tell me? Special quadrilaterals and proof. I'm going to have you read the rest of the lesson introduction and then read problem 7-49, including letter A. Press pause, read through, and then hit play when you're ready to resume. So as you read, they asked us to trace this triangle and include the angle markings when we trace it. I'm going to have you also add what we call tick marks. 1 there, 2 there, and 3 there. Include that on your traced triangle as well, and then rotate it, and let's see what we get, what kind of parallelogram we get. Once you do so, you should get something like this. Now, read letter B and see if you can answer what they're asking. Hit pause and then play when you're ready. To answer letter B, let's use a conditional statement. If blank blank angles are congruent, then the lines are parallel. Try to fill in the blanks based on this shape. If you can't really remember, maybe look back at your notes or your toolkit from Chapter 2. Hit pause and then play when you're ready. If you answered alternate interior, you're correct. Let's take a look. Here, this angle here, and this angle here, with this transversal and these two lines are alternate interior angles. If those two angles are congruent, then those two lines are parallel. The same is true with this angle and this angle for these two sides. And the same transversal. If those two angles are congruent, then those two sides are parallel to each other. By definition, that is a parallelogram. Hey, I know what you're thinking. Man, this video is straight fire. I know. Yeah, that's how I always talk. Now what I want you to do, I want you to click the link in the description down below to open up your Shapes toolkit from Chapter 1 and your Chapter 7 Quadrilaterals and Proofs toolkit. That's going to help you organize some of your notes. All right, go ahead and do that. Like now. Go ahead and do it. So here's the Chapter 7 toolkit, the first entry for a parallelogram. What's the definition of a parallelogram? Well, that's where our Chapter 1 Shapes toolkit comes in handy. Right here. A parallelogram is a quadrilateral with two pairs of parallel sides. Let's copy that and add it to our definition. Feel free to write that in your notes, or if you have technology, to do what I just did. Let's also add parallel arrows to our parallelogram to show what its definition states. Those two sides are parallel to each other, and those two sides are parallel to each other. If you don't have the printing capability, then just copy a parallelogram and add the things that we're adding. On to letter C. What else can the congruent triangles tell you about a parallelogram? Well, remember, this parallelogram was the result of two congruent triangles, one rotated and put on top of the other. Because they're both congruent, we can identify other special properties that are true about every parallelogram. So let's copy it and bring it to our toolkit to add those other special properties. So here we see if a shape is a parallelogram, then opposite sides are blank. We know they're parallel, but what else is showing to be true about the opposite sides of a parallelogram? Hopefully you're looking at those green tick marks, and we're going to add those up here. Remember, those tick marks mean these sides are congruent. So opposite sides of a parallelogram are not only parallel, a special property is that they are also congruent. What about opposite angles? Take a look and make a conclusion. If you look at these angles here and here, we can see they are congruent, which means these two are also congruent. Now if we look at the other pairs of angles, this is one angle representing this angle here. We can see that it is a sum of a red and a blue angle. This is also the sum of a red and a blue angle, which means this angle and this angle are also the same. So let's add that, showing opposite angles are also congruent. For now, those are the only properties we're going to add, although we will be adding more later. Okay, we've answered A, B, and C. Now let's finish the problem with letter D. Go ahead and hit pause, read the problem, and give it your best shot. When you think you have it, hit play again. So hopefully you were able to come up with a flowchart showing that the two triangles are congruent. Here is one example of a flowchart you may have come up with that may be what you did or similar. Go ahead and copy this flowchart. Hit play when you're done. Now you'll notice that the three inside bubbles in the middle are missing their content. I would like you to fill those in. First, let me remind you that a flowchart is simply a series of if-then statements. Let me show you what I mean. We start at the top, and we're saying if side AB is parallel to side DC, then the arrow is the then. This. If that, then that. And you're going to do the same thing here. This one on the far right obviously doesn't need an if above it. Now, once you fill those in, those become the new if. And we say if these three, then the three arrows make one then, leading to this conclusion. The two triangles are congruent. So see if you can fill in those three green bubbles. Hit pause and then play when you're ready. Okay, so let's look here at the first one. If AB is parallel to DC, my lines are a little bit off, excuse me, and we look at this transversal, then what can we conclude? Well, hopefully you can see whenever we have parallel lines, we're usually dealing with angles. And one of the common angle relationships we'll use are alternate interior angles, which we're going to use here. This angle and this angle are congruent alternate interior angles. So we're going to add that into this bubble. Angle ABD is congruent to angle CDB. Now you do the next one. If side AD is parallel to side BC, then what? Hopefully you saw here, if side AD is parallel to side BC, then these two alternate interior angles are congruent. So let's add those there. Angle ADB congruent to angle CBD. Now for the last bubble, this one doesn't need any if. What is true in this shape above that would not require an if above it? Okay, hopefully you identified that this middle line segment is congruent to itself by the reflexive property. So we're just going to say segment DB is congruent to segment DB. And there, by those three circles, we can conclude that the two triangles are congruent. Do you remember which triangle congruence conjecture tells us that those triangles are congruent? If you guessed angle side angle, you're right.